Number 14, everybody's here? What? Go team. Number 6, complex conjugates. I didn't give you the snazzy name yesterday, but it is a conjugate and it's of complex numbers. Hopefully that kind of made sense. Number 8, right problem, right? Aren't these easy? Who's A, the real part? Who's B, the complex part, the coefficient? A is 13, B is 4. Number 26, someone's hopping outside. -3 minus 11i. No killing of seals occurred in your homework, right?
No, ma'am.
We distributed those negatives? Nice.
Never again after that.
Number 40. You had to not kill a puppy, FOIL it, change the I squared to a -1, and then combine. 9 minus 40i? Still rocking it? If you made a mistake, you're finding it and fixing it. Number 72. Ooh, rough. What they have you using on that
Is it
one?
only a plus?
Plus or minus, that's a typo. Plus or minus. Because see, final answer has plus or minus. Somehow it just disappeared. I don't know how.
Should be plus or minus.
Yeah, should be plus or minus right there. How come 2i? Because we reduce. Square root of 4 is 2. Square root of -1 is I. Pull out the 2 from everybody. Now hold on. Wait. What? Look. Look at my mouse. See where he is? Second to the last step. Yes, there should be a minus. All right, fine. We got that. Question. What do you think is one of the most common mistakes for people to just quickly do and not think about?
Cancel.
Cancel the 2's. Ah, but that's not right, is it? That's killing a kitten. You have to, how would you properly do it? Isa, Luke, shush. Isa, where's your homework? You gotta be grading. Oh, because you were done. But I'm just talking about real quick. You could have killed a kitten just without thinking. The 2's would have canceled and you would have been, totally wrong. The proper way, pull out a 2 from the top. Since it's shared, you would have gotten -3 plus or minus I. The 2's could then reduce or divide both by 2. Either one, right? Okay. And with that, we're done. I heard there was a little bit of discrepancy with the odds. Do you guys have any particular ones? You're like, Jesse.
Okay, so, because I have like one big question and then 2 little ones.
Okay, what's one big one?
Okay, number 13.
Number 15? 13. Okay. 13 says, write the complex number in standard form. Oh no. 27 is not a perfect square. What'd you guys do? What times what is 27? That's a good start. 9 times 3. 9 is a perfect square. So I could make this as 2 minus 3 root 3. Square root of 9, square root of 3, 9 and 3 make 27, square root of 9 is 3. But the negative, I have to deal with that. How do you guys deal with it? Put an I at the end and make sure it doesn't look under a square root. Does that kind of make sense? Or the 2 smaller ones?
Okay, so number 51. No,
53.
53. Okay, this is kind of like
Sorry.
okay, this is more of like a general concept.
Okay.
But okay, so because I know you have to multiply the entire equation by 4 plus 5i.
Good, the conjugate.
Yeah.
But how do you multiply? Yeah. Yeah. But to keep it balanced, we can't just put it in one place. We have to put it in both the top and. Does that make sense?
Yeah.
Okay.
But I mean, like, if you're changing the sign of the 4 minus 5i to positive, why wouldn't you change the 4 to negative?
Because we're actually not. If we were just making this opposite, we would do both opposite. But we're not multiplying this by a -1. We're multiplying by what we call a conjugate. And a conjugate says if you have A plus or minus B, let's just say A minus B, the conjugate is A plus B. And we're forming basically what would multiply and make a difference of squares. So we're not trying to make it the opposite. We're trying to just make the in-between sign opposite so that when you distribute, your first you still have. Your outer and your inner are opposite signs. So we're not making this opposite. We're trying to get our outer and our inner opposite so that they cancel. then you end up with that minus 25i squared. So we're just trying to get a difference of squares, and multiplying by the conjugate gets us that where we only change that sign.
Okay.
Is that cool?
Yeah, and then my last one is for number 61.
Okay.
Okay, so for that one, I know that you have to multiply each one by like the
Yeah.
other.
Mhm.
So when you multiply the 2 over 1 plus I, would you have to multiply it by negative 3 over 1 minus I? Or
No, because we're not needing to make it match this one. We're just needing the denominators to be the same. And the only way to make these two be the same is to get both in the denominator. So we're just going to steal that 1 minus I, top and bottom. And the top's going to change somehow. But the point is now the bottoms will be the same. Does that make sense? Any other odds or evens? Going once, twice. Okay, so let's get out of here. Right click does not work. Notes open. Back to where we were. Section 2.5. If I go into our calendar, theoretically, if I go into our calendar, located online, go under Honors Pre-Calc class calendar. Here it is. Theoretically, today we are what? Wait, that's an Honors Pre-Calc? What is wrong with your guys' stuff?
You're on the week before this week.
Oh, we're down. I'm like, that does not make any sense. There you go. Whew. We're starting 2.5. Thank you. And tomorrow we're finishing. So theoretically, the homework is due on. But let's see how today goes. Here we go. 2, a point, a 5.
5, 6, 7.
Let's go.
I'm going to come back and change your board in just a second. However, for right now, what did you guys get? All right, stop doing your victory dances. Question. What did you get for example number 1? How many zeros could, should, or does it have to have? Does it have to have one?
Yes.
It could have one. Why does it have to have one? What kind of line is it? It has to hit the x-axis, right? So how many zeros does it have? Just a 1. And how would we find it?
equal the equation.
Equal the equation to 0. So therefore the 0 is at 2.
I see what
Now I didn't actually make you guys solve it, but maybe you did anyway. This guy.
Come on.
Okay, letter B. It's okay, you got this. Letter B. How many zeros could it have?
1 or 2.
1.
Could have up to 2, which means 0 or 1 or 2. How do we know for sure? Without solving. Oh, well, exponent says up to 2, but how do we know for sure whether it's 0 or 1 or 2? The degree says how many it could have. Leading factor gives me a clue, but I need to know leading factor and where its
Starts.
vertex is. Couldn't we quickly do x equals negative b all over 2a, which is at 3? So question. 3 is the x value, right? Do I know how high the vertex is? Not yet, but how can I find how high the vertex is?
Put the x into the
9 minus 9, 9 plus 9, 18. 18 minus 18 is 0. If we're doing that and doing that, question, how many zeros is it going to have?
4.
Just a 1. Anyway, but we can say up to 2. It's really just going to have a 1, right? But, Karina, you're totally right. If we can, which we can, factor it, we end up with, guys, who is this factor? X minus 3 times x minus 3, x minus 3 squared, which means my 0 is at x equals 3, and technically, what's the multiplicity at?
2.
Because it's x minus 3 squared. And it bounces. Hey, it all makes sense. Cool deal. Letter C. How many zeros could it have? I'm going to say up to 3. Good question. What does that mean, up to 3? Could it have 0 zeros?
No.
No.
It can have 1.
Why not?
No, it could have 0 zeros.
Doesn't
No, it
something-
has to
Negative
cross.
coefficient.
Well, even then,
Oh, yeah.
it's gonna
I thought
have
it
to
was-
hit, right?
Yeah.
So it was like flat.
Oh, yeah, no.
Sorry.
So it's gonna have to hit at least once. So it could be 1 or 2 or 3. How do we know for sure? Well, we could try to, I don't know, figure out something. Or factor it if possible. Yay. So set it all equal to 0. Pull out that common x. I have x squared plus 4. How many zeros does it have? It looks like 2. Looks almost like 3. But it only has 1 real one. Why? The one real one is at x equals 0. Question. What does the x squared plus 4 get us?
Plus or minus 2 imaginary number.
X equals 0 or x squared plus 4 equals 0, which means x equals plus or minus square root of -4. So it has 1 real 0, and it technically has 2 complex zeros. At plus or minus
Can we just put 2i?
2i. Plus or minus 2i. Hold on, let me get whatever's going on down with my taskbar out because it's in my way. Oh, I just thought of something. My sound was off. Hey guys, nothing's selected on my taskbar. Any ideas as to how I can get it to disappear? Why is it disappearing?
Try right clicking.
Yeah. Is it locked? Is that what's going on? No.
I have no idea.
What about unclick show task view bar? Unclick that one.
Task view button?
Just click it.
I don't know.
No, that just remove the box.
Struggle. Alright, keep going. Alright, rational zero test. Oh no, we have notes again. So, here we go. Rational zero test. Relates possible zeros to leading coefficients and the constant term. Guess what? We're in the section where it's going to say, hey, here's a polynomial. Go find all of the zeros without giving you one to do synthetic division. Without giving you one where you can just factor out common factors and get something nice and pretty and simple. Bravo. So if we're stuck with a yucky polynomial and they say, hey, go find zeros if there are any, go find the real ones and the imaginary / complex ones. Stink-a-dink. We're going to have to figure out the different candidates in order to test, either with synthetic or with plugging in. And the way to figure out all the different possible rational, aka nice zeros, is by taking the first coefficient and the last coefficient and dividing all the factors of each. So for factoring, remember we multiply the first and the last of a quadratic, but for anything bigger than a quadratic, if we're trying to figure out who are the possible zeros or solutions, we take the first divided by the last, but not just the first number and the last number, all the factors of the first number. Ooh, I'm doing it backwards. All the factors of the last number divided by all the factors of the first number, and they could be pluses or minuses. Now, there's probably a few things that you don't like on this page. Number 1, there's a weird division. Number 2, there's a plus or minus. Number 3, it says all the factors, which means there might be a lot of different numbers. And number 4, it says trial and error in the steps. We'll get there. But actually, we already did a problem from this section. It was at the end of section 2-3 where I gave you a polynomial and said factor and said, okay, who's someone that could go in? Lucky for you guys, you tried it one and it actually ended up working, so we were good from the get-go. These will necessarily be as nice. Not all of these will necessarily be as nice. But some will. do we do trial and error with all the possible rational zeros? We try one. How do we try it? Either plug it in, if it's nice and easy, or if it's not nice and easy, remember how synthetic might be a little bit easier? You can find the remainder. Long story short, a solution works and makes a real factor of a polynomial if the remainder is 0, hence if the function value is 0. So either plug in and see if plugging in gets you 0, or do synthetic and see if the remainder equals 0. If either of those are true, he works. Divide, see who's left, and keep going. Got it?
Got it.
Close? Guess it's not gonna work.
Jeez.
Woo! It's a 4th degree polynomial and it says go. Doesn't give us any clues, doesn't give us one that works.
Crazy.
Now, focus. A little intense. A little bit. Nice thing is, what's the leading coefficient? 1. Which means, for my possible zeros, my possible, technically, possible rational zeros, just to be all specific, we're not going to find imaginaries by doing this. We take plus or minus all the factors of 6. 1 goes into 6, 2 goes into 6, 3 goes into 6, 6 goes into 6, done. Over all the possible factors of 1. Oh, whew, that could have been bad. So what are all the possible zeros? Plus or minus, divide, 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 divide. And I have 1, I have 2, I have 3, I have 6. It was easy. We were just dividing by 1. I took all the factors of the last, like we wrote down in the formula, divided by all the factors of the first, with plus or minus. We figure out all the different possible combinations, which dividing anything by 1 is itself. Oh no, there are 8 zeros, and this thing can only have up to what? 4. Maybe they're all real, maybe some are imaginary, I don't know. So are all of these going to work? No. How do you figure out which ones do? Plug it in, or do synthetic. Now, what do you think? Mental, even non-mental mathers might still want to do with maybe the 1s. Yeah, because 1's kind of easy to plug in, right? So I would test.
What is the 1, 2, 3, and 6 from?
Oh, dividing by 1. Because if this was like a 2, I would have to divide everything by 1 and then divide everything by 2. So I was just showing you look for all the factors of the last term over all the factors of the first term, and then you put them all together, which just stay the same.
But if there had been a 2,
Then we would have like 1 half, 2 half, 3 half. Well, 1 half, 2 half, 3 half. But since there's just a 1, 1 divided by 1, 1. 2 divided by 1, 3 divided by 1, 6 divided by 1. Does it make sense where this comes from the formula you wrote down?
Okay.
Factors of the last term? All of those, right? Factors of the first term? Just 1.
Okay.
So what goes into 6? What goes into 1? All the ones that go into 6, all the ones that go into 1, and then we pair them all
Makes
up.
sense.
Is that better?
Oh.
So how do I test?
6 and 1.
X equal 1. You guys already tested? What happened? 1 minus 1 plus 1 minus 3 minus 6. Careful. Don't count it. 1 minus 1 is 0. 1 minus 3 minus 6. Let's just say that's not 0. Why am I saying that? I don't really care what it is. I'm not graphing him. I just need to know, is he 0? Because if he is, sweet, he works. I'll use him for synthetic. How about 1? Mm-mm. Could we maybe plug in -1 because he's kind of fast? Why am I plugging in? Maybe it's easier than synthetic if the number is small. Plugging in -1. -1 to the 4th is 1. Minus -1 cubed is -1. Plus -1 squared is +1. Minus 3 times -1 is -3. Minus 6. 1 plus 1 plus 1 plus 3. Minus 6.
Oh, zero.
0. Woo! So how are we going to start our synthetic off? Use him. Remember, x equals -1. This is a. Now what does he point to as a factor? X plus 1. But I already have it solved for, so I can use that number. Does that make sense? Or x minus 2, x
But you
minus
still
3.
use the whole equation there for the
Yep.
synthetic, right?
Come on, amazing synthetic people. Oh no, I can't extend. Oh, I can extend. This is weird.
Synthetic.
Oh, stink. There we go. Oh, this is rough. I need to get rid of this taskbar.
Oh.
You guys better be doing synthetic. If you can't multitask, you better be quiet.
The left is 0 there.
Now, who do I have so far?
Negative 1.
I have that factor with that 0. Who's this guy now? Guess what we're supposed to keep doing. Now last year, you might have built these synthetics together. In that you might have taken these same coefficients and said, okay, here we go again. But, to be honest, I guess we could start right away with synthetic. Couldn't we technically test -1 again? We know that 1 doesn't work. 1 doesn't work from the beginning. X equals 1 isn't going to work at all. But couldn't -1 be in there twice? And if he doesn't work, where are we going to go to next? Well, these are the same exact numbers as the beginning, so then we'll go to +2 then -2, then +3 then -3, then +6 then
You already have
-6.
a nice and easy factoring to do.
Cubic, though.
Still, you x squared plus 3 x and -2.
Now, Luke is kind of looking and
1 and
saying,
2,
hey, you
3
know
and
what?
6.
Sometimes grouping works, and he just tried grouping and it worked. What? Now, is it always going to work? No. But what did he see? He said, I wonder if it works. Now, is that a good strategy? Yeah. Is it always going to work? No.
No.
But since this one does work, let's pull out that x squared. And what do we get?
X minus 2.
X minus 2. Hey, guess what would have worked? 2, if we got in there. Plus, pull out a 3, x minus 2. Once again, with cubics, grouping doesn't always work, but he just saved you guys a bit of trouble. Why? Hey, kiddos. Why did he save you trouble? We wouldn't have tested +1 again. He didn't work at all. We might have tested -1 again. Guess what? He wouldn't have worked. He's not in here. Then we would have gone to +2. Then we would have seen it worked, that it worked. Then we would have gone to synthetic division and gotten basically this that you see here. Wait, this. We're not done yet. What can we do with these? Yeah. We can pull out the x minus 2. We have an x squared plus 3, but be careful. Who else should technically be there?
The x plus 1.
Right? And why should all of that be there? Because we're trying to figure out the zeros of who?
Oh my goodness.
If I can get this taskbar down, I can scroll down, but sadly I can't. Los Santo people in the back. How do I set it equal to 0? Struggle. My extend page is right here where I can't get to. There has to be a way. You guys are finding your zeros now, right? Can I do that? Did I just get rid of it? There. Whew, praise the Lord. There we go. Okay. So what are your zeros? X equals -1, 2, and plus or minus. What? How did I get there so fast? What did we do? We said define zeros, then we have to set everything equal to 0, right? Which ones can we do in our heads pretty quick? That's -1. That's +2. That's -3 square rooted plus or minus. How many zeros is every fourth degree going to actually have? It's going to have 4 zeros, but not all of them are necessarily real, which means not all of them are going to be seen on the graph. So, it does have 2 real zeros and 2 imaginary. A fourth degree actually now we can say is going to have 4 complex zeros. Some will be just real and some might have imaginary pieces. Just
Where did the X plus 1 come from?
we had already divided him away. So when we were looking for all the factors of the polynomial, we stole this, but we had to go back and say, oh yeah, and we already had him as well. Does that make sense? Yeah.
So now graphing is not reliable because of multiplicity and
Graphing is not reliable for imaginary zeros.
and multiplicity too now.
It won't show multiplicity, but you can see multiplicity because it'll be bouncing off at that zero.
Oh yeah, true. Ooh.
Another one! Go! Wait, I'll help. Just at the beginning.
And if you have multiplicity of 30, where you can.
Could. But it'd be odd, so it'd cross through it.
Yeah.
So that one we could. We just know even or odd. That's all. Possible rational zeros. How do I find possible rational zeros? Plus or minus all the factors of who? The constant, so the last, over all the possible factors of the first. Wait, do you know where I got those numbers? All the possible factors. Who goes into 3? 1 and 3. When we're talking about just natural numbers, whole numbers, technically. Who goes into 2? 1 and 2. Done. So what are all my possible rational zeros? 1 over 1. 1 over 2. 3 over 1. And 3 over 2. Plus or minus all of those. So 1 over 1. 1 over 2. 3 over 1. 3 over 2. Now, which one are we probably going to start testing first? We're going to test. With synthetic division, thank you. I can plug in 1 just fine. You too? So, let's test. X equals 1. F of 1 equals 2 plus 3 minus 8 plus 3. Sean. I've actually already done this one. But that's okay, do it again.
Oh, whoa.
Do you remember him? Try. Cheaters, you got this. Who goes in the box? The 1, because we know it works. You have the 2 and the 3 and the -8 and the 3. Whoa. Hold on, I want you to keep going though. Let's do our synthetic real fast. No, because x equals, when we plug in a number, we're plugging in the A. We're plugging in the A. So he's the number that goes in the box. Remember, what does he show me as far as factors? He shows me this one. X minus A. Does that make sense? Bring that. Look at that glorious 0. And 0 is there. Synthetic division and okay. Open that one.
You can group with this one as well.
Steve. This one. I have to go do synthetic again. No, I don't. Because Who is he? He's a quadratic, yeah, right? So I can take my f of x, where's this big old nasty blah blah blah, and I can say when I divide it by, wait, what does the one indicate again? X minus 1. I got 2x squared plus 5x minus 3. And the other day when we did it longer in section 2, 3 at the very, very end, we did our whole multiply the first and the last and figure out the right combination and group and all that stuff. Long story short, we ended up with x minus 1 times 2x minus 1 times, did I have the last factor? Got it. I know. I cheated. You guys know to factor quadratics if you took enough time, right? Multiply first and last. And you have it at the end of section 2, 3 if you want to make a note to yourself to look back. What am I trying to find? The factors. Look, the directions. Done. What if they ask for the zeros? Then you solve. But if they say factor, you better not go any further. Now hold on. Did these possible rational zeros work? We have 1, we have 1/2, and we have -3. Oh, they all would have been there. Along with a lot more. But they were all there. Any imaginary zeros? Nope. So how many intersections would we see in the graph? 3. Make sense? Just a second ago, not the last example, but the other example, when we did have complex zeros, when we did have square root of 3i, did you guys notice that we had plus or minus? We had plus or minus? Guess what? If you have one complex zero, you have 2. If you have one complex zero, you have 2. Why? Because they always come, this little clue, this little hint says, they always come in pairs. Technically, we could say they always come in conjugate pairs. And Jesse, this kind of goes to your question earlier in the sense of, it makes sense why these two are conjugates because same first, same last, the signs are different. How is he a conjugate? Isn't he just opposite? How is he a conjugate? What's the first? With conjugates, there's always 2 terms and the middle sign switches. What's his first term? 0. From imaginary numbers, we talked about if there's just an imaginary piece, it's like a 0 for the real piece, right? So 0 plus bi, 0 minus bi. Oh, it's a conjugate. So if you have one complex 0, you have 2. So if, for instance, in a homework problem, they say something like, hey, you have a complex 0 here, and they give you 1. What could you also then say? You have another. And which other? Whatever the conjugate pair is to the one they gave you. Well, it's whatever they give you. Let's say they say 2 plus 3i is a 0, a complex 0. You can say, oh, sweet, 2 minus 3i is a complex 0 too. Just depends on what it is. Anyway, little tidbit, it's going to be helpful when we get there. Uh-oh. When we get where? When we get here. They don't even give you a polynomial. They give you clues. Oh. Wait. Come on. Come on, my problem
The
solvers.
opposite.
Let's go Warriors.
Question. Write down your clues and think. Don't just blurt it out. Let people think. What are they telling us that we can start writing down to form or make or show the polynomial that meets these conditions? They've given us hard facts, degree of 4. All the coefficients are real numbers. The zeros are -1, -1, and 3i. Why is he asking? she asking? There's always pairs. So if they told us there are zeros at -1 and -1 and 3i, what can we also say? You were trying to trick us and didn't give it to us, but we know that there must be one at -3i also. Good. That's one thing that we can say. Wait, that doesn't make sense. There's supposed to be 4. Oh, these come in pairs. Now they're pretty nice.
Wouldn't you do like x squared plus 1 and then x squared plus 3?
Close. But x squared plus 1 would give us plus or minus I, not -1 twice.
So then x plus 1 plus 1.
Wait, what's she doing? When she said x plus 1, x plus 1.
She's get out of the
She's seeing these as zeros to who? Factors, and she's starting to build. So we can build, we have x plus 1, x plus 1. What's this going to be? X. Weird, but true. And what's this one going to be?
Oh, and then for the i's, can we put them back into the root form by going in reverse? So like, let's say if it's 3i, we know that it would have to be the square root of -9. So then we can do that for both of them, keeping the signs on the outside, and then we can FOIL.
That's true. Or
Just x squared
make it
plus
simple.
1.
Couldn't we just FOIL the way it is and make it real when we?
So
then-
x squared plus 3.
I see you.
She got me.
No, we're trying to find the whole polynomial. So this one's going to be x squared plus 2x plus 1, right? That's this foiled out. But what else do we need? They said, look at here. They say real numbers. Right now, I have imaginary numbers. Not true.
But I know that comes from 1x squared plus 3, so I just put x squared plus 3.
Not plus 3.
Plus 9.
But the 3i squared is going to be the I.
X squared plus 9.
9.
Because plus or minus square root of 9 is 3. Does that make sense? Well, if you know. If you know. But just don't ever make a mistake. Okay. No pressure.
Well, it's not square root of 3i.
Yeah, it's not square root of 3i. It's just 3i. Yeah. Oh. I foiled fast. Oh, I'm sorry. X. Oh, but this one makes sense?
Yeah.
Okay. Then I did difference of squares. So I did x squared. I knew that the outer plus 3ix, inner minus 3ix cancel. And then I did negative 3i times positive 3i, then negative 9i squared. Oh. Remember I squared is negative 1. Negative 1. Yeah, I squared is a negative 1. I'm so close to my polynomial. Isn't he a quartic just because of what we've built? We just need to finish. Okay, we got this. Now it's just polynomial multiplication. So now we have x squared is x to the 4th. I'm just going to do each term twice, okay? So we have plus 9x squared, then we have plus 2x cubed, it's his turn, plus 18x, plus 1x cubed, plus, ooh, yeah. Let's make him pretty. X to the 4th, x cubed, x squared, x term,
Obviously, it's an x squared before the plus 9. So it's 10x squared.
Yeah.
See the plus before the plus 9
It's
above?
1x squared.
It's 1x squared, just 10x squared.
oh, I did multiply right? X to the 4th, 9x squared, 2x cubed, 18x, 1x, bummer man. There should be one more. Went too fast. 9x squared, 1x squared, 10x squared, plus 18x, plus 9. And I didn't write my squared. Woo! Who is that? A polynomial with a degree of 4 with only real coefficients and with zeros of -1, -1, 3i, and -3i. What? Does that make sense? it a little tricky at the beginning? But did they give us everything we needed?
Yes.
But was Brandon's clue of, hey, if there's a positive 3i, there should be a negative 3i? Was that? Yeah, nicely done. So, we're done. Right? Not quite. But look, wait. After this page, we have a couple things. We should finish fast. What is this nasty page?
That's just the start.
Oh!
That's just a review of what we
It's just summarizing everything we just did.
Cool.
Identify the possible rational zeros. Rational zeros. Test them. How? Synthetic division, maybe. Plug in and see if it's 0. If it's fast, maybe. Other tools. Oh, maybe we'll learn a couple more tomorrow. Then use your calculator to narrow down the forces of variables. But we don't like cheating with that one, right? Question. Homework is not going to be due tomorrow. No. Question. Homework is not due tomorrow, right? Nice. When is homework due? But you guys have seen these problems. Question, do you want to leave all of this homework for the weekend?
Yes.
You guys have great plans of having a fun weekend. Lame sauce, you should start tonight. So, question. Look at that whole skirt. Your homework tonight is not nothing, it's to start.
To start. How many? Is it like 20 copies? More? Too much.
I don't know. Football player, your water, come get it. Luca, somebody.
I forgot my gun every day. My mom.
Every day, he's coming.